Hello and welcome to this new tutorial, and in this tutorial we are going to learn how to do moving object detection using background subtraction method using EmguCV. And here is a little demo that I want to implement in this tutorial. We will select a video. So we select a video, and now you can see that the object is being tracked here. The object is here, the person, and we are drawing a bounding box or a rectangle around the moving object in a scene or in from a video. So let's see how we can do this. In OpenCV, there are various background subtraction methods, and the overall working for these methods is similar, the way we can implement them. But there may be some will perform better than the others, and one of the most popular method is the Gaussian mixture based background or foreground subtraction method, which I will implement in this tutorial. And the basic idea of any background subtraction method is when we are given two images, the subtraction model will try to learn what is the background, and then these two frames or these two images will be subtracted so that the only moving object or the foreground, which we call it, will be estimated. So this is what we are going to do now. So let's implement it. I already configured a project that uses EmguCV 4.5. So let me go to this segmentation and create a new menu, called it extraction, and double click on that. So I will do a try catch block first. So first thing that I will do is video capture. We can give it a name like capture, and let's say it is null. And also I need a background subtractor. So let's create an object of background subtraction using a emoji. We can call it background subtractor, or we can do later, we can change any of the background abstractor. So I will use this background subtractor so that we can create any object of the abstractor background abstractor method object, and then we can use it. So the first thing that we will do is ask the user to select a video. So I'll be using open file dialog. Let's say dialog is equals to new dialog object. And since I'm going to use only the videos, so I will apply a filter, and we can say video files, and their extension could be .mp4. You can add as many as you want, and star.avi semicolon. So this will be just the description, but the most important thing is you put a 5 and then put this one like this. So this will be the extensions, and then we can show the dialog to the user. Show dialog, and if he selects some of the any video, then the result will be dialog result.ok, which means he or she selected a video. And then we can, once it is selected, we can create a capture object. Now we are ready to read it, and which video we want to read is the video that the user has selected. So I give the parameter to the video capture object, and to make sure that it is not null, so that we read a video. And what I want to do is I want to read the first frame and display it in my picture box. So I can create a made object, say that is a frame is equal to new frame, and then from the capture.read method, and this one is expecting some output array. So this is the frame that I'm going to give to it. It will read and write into this frame, and I just want to show this one in my picture box as image, and this one we will call it 2-bit made. So let us run and see if it can read my video or not. So let me click on start. So let's go to the segmentation, background extraction, and you can see here only this is the extension that is acceptable. And let me select this video and open it, and it's perfect. So this is the first frame that we read and display it in the picture box. What I want to do is now I'm sure that the video is can be read by the video capture. So we can create the object of that background subtractor that I already created is equal to new. Now here as I use this one as the interface, so we can use any of the background subtractors. So background subtractor, this MOG2, that mixture of Gaussian. So I'm just going to use this one, and there are different parameters, how much history it has to maintain and what should be the value of the threshold, should we detect the shadows or not. So all these parameters you can play with. I just want to use the default parameters. And now what I will do, the easiest and its simplest way is to use the application.idle method to capture each frame. So I will be using, since I'm using this Windows form, so that will be more suitable for me. So application.idle plus equals, we can create a new event here. So what it will do is basically when we grab a frame, then it will go into for very short interval of time, it will go into an idle state, and then we will capture the next frame, and then it will be idle. So in that state, what I will do is process the frame and display whatever I want to do here. So I will take advantage of that, so before it grabs the next frame. Okay, so here I will do is the try catch, and if there is any problem, I can throw a new exception object, and whatever the object gives me the error, I just want to. Okay, so let us read a frame, and I call it frame is equal to capture dot query frame. So we grab a frame from the video, and I need to make sure that if this frame is empty, I assume that at the end of the video it will be the empty of it. So I just want to make sure that application dot idle, what we did earlier should be the same. So I just want to copy and paste it here, and I just want to remove this event by putting a minus sign here from the application, and I will also return. I will do nothing. Okay, this is okay. Once we have the frame, we can process it further. The first thing that I want to do is to smooth this frame using the Gaussian method. So I need to create a new made object and call it smooth frame is equal to new made, so that I can store the result here, and then I can use the CV invoke dot Gaussian blur method. The input will be the my frame, and the output I want to store in the smooth frame variable, and the kernel size that I use is 3 by 3, so I am happy with it. The results are okay, and the sigma I just want to put a value of 1, and the default other parameters I don't need them. Once I smooth the frame, the next thing I will do is to directly apply the background subtractor. So first I need to create another object of type mate, and we can call it foreground mask to store the result after applying the background subtractor. And then we can apply this background subtractor. This is the object I created for Gaussian mixture model, and there is a apply method, and you can see the two main parameters that I need is the input image, so that is the smooth frame that I want, and the output I want to store is in the foreground mask. The rest of the parameters I will use the learning rate as default. So that's it what I needed, and we can see the results. Picturebox1.image is equal to foreground mask dot to bitmap. So let us run this application and see what the background extractor gives us as a result. So the segmentation, background extraction, and I'm going to select a video. Wow, so you can see this is the background extraction results. But I'm interested in only detecting the moving persons, not something else. So you can see there are some other objects also. There are some background, or although it looks like they are static, but maybe the motion in there is some motion in the camera, and of course the human are moving. So I need to apply some post-processing. Just I want to identify these humans. So what I will do, there are some different things that I can see is the humans are taller, their width, height should be more than the width. And also I will remove the nearest effects, the gray effects, only the white parts I'm interested. Maybe we will do some closing to remove such kind of noise from it. And also there are some small objects which I don't want them. So we need to find out the area of their bounding box of all these, whatever the elements are, the contours we have, and we will try to filter them out. So post-processing will be the thing that we need to do in order to obtain more accurate results. So what I will do here is to first apply a threshold so that I have only the white regions, dominated white regions, and I will apply a threshold. And this one is asking for an input image. So the input image will be the foreground mask. And also I don't want to create a new, so the results will be written back into the same uh, object. And the threshold that I want is, let's say, 200. And the maximum that I want is 250. So whatever the values, the gray values, I don't want them, only the white regions I want inside my output. So the method that I'm going to use is the threshold method dot binary method, and that's it. Another thing that I can do is to suppress small objects, is to apply a morphological closing operation, which is basically a combination of both dilation and erosion, so that the small unwanted objects I may be able to remove them. So I will use this morphological EX, which basically performs some extended operations beyond the basic erosion and dilation. So here I'm going to provide the same foreground mask and also the output as foreground mask, and the operation that I want to perform is basically the close operation. And this one is expecting a kernel, so I'm going to use this made object dot ones. So I'm just going to create rectangular or square objects. So I'm just going to give a 3 by 3 is enough, I think. But if you think that our objects are longer, I mean their height is higher than the width, maybe we can give more rows and less columns. Let's see the results if those are satisfactory or not. And maybe optionally sometimes this, not optionally, we need to provide the depth, and the depth will be CV8 with unsigned, and the channel is 1 because it's just a mask. And next is the anchor point. So what should be the central point? I said this should be -1 -1, indicating that the middle of these will be our anchor point. And the number of iteration 1 is enough, and border type that I want to do is to replicate or reflect, doesn't matter. I mean on the borders what it will do, because the size of our kernel is when goes it outside, what will happen. And the last parameter is the border value. But when I say reflect, I don't need to provide it, but I'm forced to provide it here, so I just give a set of 0. And this is important in case of constant border. So if it is a constant, what should be the value that we will use? Okay, so this is I did the smoothing and this thresholding and followed by some morphological processing. And now I want to remove the objects which are very short, which are very small. So for that, we need to define some threshold, let's say. And to remove those objects, small objects, unwanted objects, we need to find the contours. So let me create vector of point to store the contours. Let's call them contours, and then apply cv invoke.findContours method to find the contours. So the input image that we have is the foreground mask. The outputs will be in the contours, and we don't need the hierarchy information. And retrieval type will be I'm only interested in the external contours. Chain approximation method can be simple chain approximation method. Now I need to loop through all these contours. So for integer I contours.size. So what I need to do here is to calculate the bounding rectangle of every contour. So we can say bbox is equal to cv invoke dot bounding rectangle, and we want to create the bounding rectangle for every contour, so we provide the index I. And once we calculate the bounding box, we can find the aspect ratio of width and the height, as well as we can find the area of the bounding box. So let me call it area is equal to, simply we can do bbox dot width multiply by bbox dot height. Actually, I don't need the actual pixels of the area of the objects in pixels. I just want based on the contours width and height. This is the area of the bounding box. And also we can find the aspect ratio, that is the ratio between bbox dot width divided by bbox dot height. And since both are integers, the result may be truncated or rounded off. So let me change one of them into a float. And as we know that this width should be smaller than the height for a human. So we will put some conditions here. If my area is greater than some threshold, so we need to define that threshold here. Let's say integer min area is equal to, I want 500. So it should be a bigger object. So if my area is greater than min object, and the aspect ratio should be less than, let's say, 1.0, that so the width should be smaller and the height should be greater. It means that the aspect ratio should be a smaller one. Then we can show that contour. So cv invoke dot, not the contour, actually we can show the bounding box. cv invoke dot rectangle, and I want to show it on the input frame, and the bounding box that I will show whichever the bounding box we have, and the color that I want is BG, and the red will be full, and the thickness, let's make it a little bit bigger so that we can see it. Okay, and then instead of this full background, I just want to show the frame as the output. So we filter them out, draw a rectangle which satisfies the condition, and now we will display it. So let's run again. Okay, segmentation, background extraction, and now you can see what it is doing. That looks fine, and the persons whoever moving around, even though one rectangle for these two together because of the they are overlapped with each other, and it's not a problem, but at least it is giving us that these are the persons who are moving around. For example, this person also has been detected successfully. And also, there are other methods available for background segmentation, as I discussed before, that these are now available in BG segmentation or BGSeg namespace. And there are different methods that are available, and the overall working is the same. For example, if we want to work with some other background extractor or subtractor, let's say, new, we can use one of them. For example, emgu.cv.bg segmentation, and let's try with CNT with the default parameters and see the results, how they perform actually. Again, do the background segmentation and we test. So here you can see the results. They may vary depending on the performance of the each algorithm. So, but the overall the working seems to be similar to what we have done with the MOG, for example. And the previous version of MOG is also available with default parameters. So if I try it, and the background subtraction, and again, so although when they are standing here, it missed, I mean, some part of it. So but the MOG2 was better than this one. For example, what parameters do I need to provide? Let's say with the default values. These are the parameters which we need to tune them according to our problem. So let's see how it performs. Well, I don't think that this is a very good performance, because here you can see consistently showing that there is something, but actually we are not interested. So I prefer to use this mixture of Gaussian 2 method for background subtraction. And that's it from this video. Hope to see you in another video.